Thus, the horizontal motion is a uniform motion and the vertical motion is a uniformly accelerated motion. The magnitude of the vertical component is different at different points and is directed vertically downwards. Let us now analyze the motion of a projectile thrown obliquely. Let a body be projected from a point O with initial velocity VO. The projectile makes an angle theta with the horizontal axis. The velocity of the projectile at any point of the trajectory goes on changing both in magnitude and in direction. The velocity can be resolved into two rectangular components, V0 cos theta along x-axis and V0 sin theta along y-axis. There is no acceleration in the horizontal direction. The vertical component of acceleration AY is equal to minus g. Substituting the value of AX and AY in equations 1 and 2 respectively, we get, that is, the vertical component of velocity changes with time and at the highest point the Vy becomes 0. Let us now find out the resultant velocity of the projectile at any instant. The resultant velocity v is equal to vector Vx plus vector Vy. By parallelogram law of vectors, v is equal to square root of Vx squared plus Vy squared. V is equal to square root of V0 cos theta whole squared plus V0 sin theta minus gt whole squared. The direction of the projectile at any instant is given by the angle between the velocity vector and the horizontal. Tan theta is equal to Vy divided by Vx. From the equation Vy is equal to V0 sin theta minus gt, it is clear that Vy decreases when t increases and becomes 0 at p. At this point, the velocity is only along the horizontal direction. With further increase in time, the vertical component of velocity gradually increases in the downward direction till the particle strikes the ground. Horizontal range. The distance from the point of projection to the point where the projectile strikes the horizontal plane is called the horizontal range. It is denoted by the letter R. Time of flight. Time of flight of a projectile is the time taken by it from the instant when it is projected to the time when it strikes the point in a horizontal plane passing through the point of projection. T is equal to 2v0 sin theta by g. Range of projectile. Range of projectile is defined as the distance between the point of projection and the point where the trajectory cuts any plane. R is equal to V0 square sin 2 theta by g. Maximum height. Maximum height is the maximum value of the vertical distance attained by a projectile above the horizontal plane to the point of projection. In the figure, P is the point of maximum height. H is equal to V0 square sine square theta by 2g.